we're going to go ahead and take a look at finding your greatest common factor. We're going to do this in two different methods, and hopefully this lesson will help you understand finding the greatest common factor in an intuitive idea. Well, you might be wondering, what is the greatest common factor? It's really the largest number that goes into, meaning a factor of each of the other numbers. So, like the greatest common factor 4 and 6, often written as GCF of 4, 6, is 2. It's the largest number that goes into both of them. Nothing larger than 2 goes into 4 and also 6 at the same time. You might also wonder, well, why would you ever want to find the greatest common factor? Well, you're often going to want to use greatest common factor when you're trying to simplify fractions. Consider 4 and 6 again. 4 is 2 times 2. 6 is 3 times 2. Now, we have the same 2's top and bottom. Well, if I write it like this here, we still have 2 times 2 on the top and 2 times 3 on the bottom. But you notice the blue 2 over the blue 2 is really a special form of 1. And we know that multiplying by 1 doesn't change it, so it's really just that 2/3 that we have there at the end. So let's go ahead and try to find the greatest common factor of 18 and 24. And this first method plays off the words of greatest common factor. So we're going to start out with finding the factors. So we're going to find the factors of 18. Now, I'm going to do these in factor pairs. Well, I know that 1 works, and while 1 and 18 is a factor pair, well, the next number up from 1 is 2, so I'll try that. And 2 goes into 18, and 2 goes into 18 9 times. Now, the next number up from 3 is, or next number up from 2 is 3, so I'll try that, and I know that that's 3 times 6. Now I know there's nothing else, because if I go the next number above 3, I get 4. Does 4 go into 18? No. Try the next number up from 4, which is 5. Does 5 go into 18? Nope. Next number up from 5 is 6. Well, it's already listed. Well, we also have to do the same type of thing for 24. Well, I know 1 goes in there 24 times. Try the next number up from 1, which is 2, and 2 goes in there 12 times. Try the next number up from 2, which is 3, and 3 goes in there 8 times. Try the next number up from 3, which is 4, and 4 goes in there 6 times. Try the next number up from 4, which is 5. 5 doesn't go in there. Next number up from 5 is 6. It's already listed, so I know I have all the different factors of 24. So we now want to go ahead and take a look at the common factors, trying to build our way up to the greatest common factor. Well, if we look at the common factors of 18 and 24, we have the 1's in green, the 2's in red, the purple 3's, and the kind of brownish 6's. So if I list those, I get my 1, 2, 3, and 6 as my common factors. Well, I'm really looking for the greatest common factor. Well, the greatest common factor would be the largest out of that list, which is 6. So with that in mind, go ahead and try to do the greatest common factor of 16 and 36. Pause the video, work that out, and then play it to see if you agree. So we'll start off by listing our factor pairs. After we have listed our factored pairs, we want to go ahead and find our common factors, which are the 1, the 2, and the 4. And then we want the greatest common factor, which would be the largest, which is 4. Now we'll go ahead and take a look at a second method. And the second method works off the prime factorization. So we'll go ahead and find our greatest common factor of 18 and 24, again, but in a different method. So we'll start off with the prime factorization. 2 goes into 18 9 times. 9's not prime, so 3 goes into 9 3 times. And same idea over here with 24. 2 goes into 24 12 times. 12 is not prime. 2 goes into 12 6 times. 6 is not prime. 2 goes into 12 or 6 3 times. All my numbers at the end of the branches are prime, so I know I'm done with my prime factorization. So I'll write the prime factorization of 18, which is the 2 times 3 times 3 from the previous screen. 24 is 2 times 2 times 2 times 3. And all I was doing was taking all the numbers at the ends of my branches. Not in the middle of my branches like the 9, but at the very ends. Now, what I want to do, since I'm looking for the greatest common factor, is I want to find the factors in my prime factorization that are the same, in common. So I have a 2 that shows up in both lists. I also have a 3 that shows up in both lists. So my greatest common factor then would be the green 2 and the red 3. When I multiply those together, I get 6. Now, I'm not concerned about those numbers that aren't in common. We have a second 3 in the 18, but there's no second 3 down in 24. We also have a second and a third 2 in 24, but there is no second or third 2 in 18, so that's why I'm not concerned about those. I'm only concerned about those that show up in both lists. Now, as a side note, this method does not work well if you're writing prime factorization with exponents. It only works if you do it in kind of the expanded prime factorization form. So with that in mind, go ahead and try to do the greatest common factor of 16 and 36 using this prime factorization method. So pause the video, try it on your own, and then play it again when you think you have it to see if you agree. So we'll first of all start off with the prime factorization of 16 and the prime factorization of 24. I did not show the factor trees in this case, but you can do a factor tree and get this. So then we're going to go ahead and basically identify the common ones. So we have the red 2's, we have the blue 2's. Now what's left, there's nothing the same top and bottom. So that's why they're not in the different colors. So our greatest common factor would be our red 2 and our blue 2. We multiply those together and we get 4.